Welcome to another video from ExplainingComputers.com. This time we're going to take a look at this, the Orange Pi 5 single board computer. This is based on an RK3588S system on a chip, which is a cut down version of the RK3588. And this has allowed Orange Pi to make a new board that's both powerful and cost effective. So let's go and take a closer look. So here we have our Orange Pi 5 and specifically a model with 4 GB of RAM that I pre-ordered from AliExpress. And there, this currently sells for $75 plus taxes and shipping, although there's also an 8 GB model for $90 and even a 16 GB variant, a 16 GB ARM SBC for $120. This said, prices for the Orange Pi 5 do seem to be shifting regularly, and the board is sold in lots of different bundles that include things like the required 5V 4A USB-C power supply that I already have. So let's open this up. I think it's fairly straightforward. We just get into the box at the end like that. Here it is. It's in a bag and oh, it's sealed. So we will bring in, guess who? Mr. Scissors will let us into the bag like this, hopefully. Has that worked? I think it has. And here we have our Orange Pi 5 and it looks very nice indeed. At the heart of the board, we spy its Rockchip RK3588S system on a chip, which, as I mentioned in the introduction, is a cut-down or cost-optimized version of the RK3588. Both are octa-core chips with 4 ARM Cortex-A76 cores clocked at up to 2.4 GHz and 4 ARM Cortex-A55 cores clocked at up to 1.8 GHz. And both chips also have an ARM Mali G610MC4 GPU and a 6 TOPS Neural Processing Unit or NPU. So, other than the fact that the two versions of the chip have a different package as we can see, what is the difference? Well, it all comes down to peripherals. And without covering all of the details, although I'll give you links to all of the details in the video description, the important things for us here are that whilst a full RK3588 supports 2 HDMI outputs, 1 HDMI input and PCIe 3.0, the RK3588S only supports 1 HDMI output, does not have an HDMI input and is PCIe 2.0 only. And we'll test out the implications of this later in the video. Anyway, focusing our attention back on the Orange Pi 5, flanking the top and the side of the SoC, we have our RAM, which is low power DDR4, and here 4 GB. Turning to the first long edge, we first get a USB-C connector for powering the board with a 5V 4A supply, and next to that, a 3.5mm audio input-output jack. Next, we've got a full-size HDMI 2.1 connector that supports up to 8K at 60 frames a second. Next along, we then get a Type-C USB connector. This is USB 3.1 and also offers DisplayPort 1.4 over USB functionality. So it is possible to connect 2 monitors to the Orange Pi 5, one to HDMI and one to USB-C. And talking of visual stuff, moving along, we're offered the first of 2 LCD panel connectors, and the other one is just underneath. You can probably see it on the underside of the board. And we've also got here the first of 3 MIPI CSI or camera serial interface connectors. Rotating to the first short edge, next we find a Type A USB 2 connector, although the interface for this port is shared with the previous Type C connector. In the middle, we then get Gigabit Ethernet, and then we find 2 Type A USB ports, which according to the specifications for the board are USB 3 on the top and USB 2 beneath, although they're both here coloured blue, so maybe the specification is wrong and they are both USB 3. Spinning 90 on our second long edge, we find some indicator LEDs, a UART connector and a 26-pin GPIO connector. And repeating our rotation trick for a final time, we discover on the second short edge a microSD card slot, an on-off button and an onboard microphone, which is a really nice touch. Back on the top of the board, there are also masked ROM and recovery buttons to be used if we really get into trouble, as well as another camera connector. However, what we don't find is a wireless module, and so there's no onboard Wi-Fi or Bluetooth on the Orange Pi 5. This said, if we flick the board over, it shouldn't mind too much. There we are, it didn't. What we find underneath are the second LCD connector. We mentioned this earlier, it's poking out on this side of the board. And we also find a third camera connector and an M.2 slot. And this is M-keyed for supporting an NVMe SSD. However, Orange Pi have said that they'll release a custom M-keyed M.2 wireless module to fit this port. Meanwhile, some users online have also reported success using a standard B-keyed wireless module in an M.2 M-key to B-key adapter. However, this is getting a bit messy, and even using an NVMe SSD in this slot is going to be trickier than it might be because of the orientation that way rather than that way. We'll have to use a 2242 NVMe drive to fit on the board and be secured using the mounting hole, using hardware that isn't actually here. It's going to be more difficult than that to use a longer, say 2280 drive, the more standard size of drive, although that's exactly what I'm going to do later in the video because I want to run an NVMe test. So there we are, this is the Orange Pi 5, a very nice RK3588S single board computer that sells for around half the money that you pay for some other RK3588S SBCs. That's going to be a good achievement by Orange Pi. And so now it must be time to find some operating systems and to test out the board's performance. Right, I've now got everything connected up and I've added a small heatsink as you can see. So let's turn on the power. There we go, and we're booting up into a desktop version of Ubuntu 2204, which is one of several operating system images provided by Orange Pi, with the others including Debian and Android 12. And as usual, this is not my first boot. I have gone in and made a few scaling changes, but other than that, you're seeing the operating system exactly as you get with a fresh image. And as you can see, we're definitely on an Orange Pi. We can't mistake that. So let's go up to the menu, see what's pre-installed. Not masses pre-installed, allowing you to install your own stuff. We've clearly got things like the file manager, which will come up like that. It's set not to show window content while dragging. I normally turn that on, but I thought I'd show you what you get out of the box, as it were. Nothing wrong with that, just depends on your preference. We've also got loads of settings, as you would expect here in Ubuntu. Reasonable number of accessories pre-installed. I think there we are down there. We've got Genie installed for development, always good to see. Not much under graphics. Help, of course. Chromium web browser. We've got Audacity, look, under multimedia. You don't always see that pre-installed, do you? The Audacity audio package. Always nice to see Audacity. There it is, Audacity on the Orange Pi 5. But however nice it is, I'm going to close it down, so we'll continue down here. We don't have an Office suite pre-installed. I'll add one later. And under System, we've got the usual type of tools. Let's run up the system monitor. Let's be graphical, see what's going on in the system with its 8 cores, which aren't very busy right now. Chunk of memory being used as we're just idling along and running with System Monitor, but things are clearly going okay. So let's go to a browser, key part of a desktop experience. Let's go down to Internet and Chromium, which is the default browser here, which hopefully will take us to the ExplainingComputers website. It has done. The browsing experience here is very good. Let's click on SBCs, check out some SBCs on the ExplainingComputers site. There's lots of SBCs here, you know. I've reviewed so many boards over the years, including, down at the bottom here, 3 other Orange Pis. There we are. In fact, 4 other Orange Pis. The last one wasn't technically an SBC. And I just thought I'd let you know that I've got a video coming up called Raspberry Pi 4 Alternatives, where what I'm going to do is to return to some of the boards on this list, some of the boards I've looked at in the past, see if they're still available, see what the software support is, see if they are right now a viable Raspberry Pi alternative. Anyway, let's do something a bit more demanding on the web. Let's go to my bookmarks, and hopefully I've got various things bookmarked. I bookmarked Amazon, just because Amazon is quite a demanding website to bring up, and as you can see, it's got no problems at all. The web browsing experience here really is very good. Having the RK3588S, it just gives us a very responsive single board computer. And some of you have asked me to include various tests in my videos from now on, so I'll do a little bit of that. Let's go to bookmarks and go down to this, which is a WebGL test. Here it is, and this doesn't do terribly well. It's trying to bring up all these fish in the tank. It's got them running now at about, what, 3 or 4 frames a second if we're lucky. Why is it so slow, you cry? Well, the reason is, we can see if we go to another bookmark here, we go across to there, we can check if Chrome has got hardware acceleration running, and clearly it hasn't. It's doing everything with software. And that's a bit of a shame, but it's also not that much of a surprise we don't have hardware acceleration enabled in a browser. We often don't on SBCs, particularly ones with a Rockchip system on a chip. But anyway, let's go to the place you will expect me now to go, which is YouTube. It is there. Let's play my sample YouTube clip, bring that up, just get through the ads and stuff. And there we are, running through with Stats for Nerds on. And the playback here, even though we haven't got hardware acceleration active at the moment, is very good. Very few drop frames. And I'm sure this is because we've got an octa-core SBC. We've got enough power here to play back streaming media without having to rely on the GPU. So I'm quite impressed with this. It is certainly the case you could use the Orange Pi 5 as a nice little small low energy desktop computer. For basic desktop computing tasks, it works very well indeed. Greetings! I've now connected a WD Black NVMe SSD to the board. It sticks out a bit, as you can see. It's supported in place with an SD card adapter, but it'll work okay. And if we go across to the Ubuntu desktop, here I've run up a terminal, as you can see. So if we do an lsblk, a list block devices, we can see everything connected to the system. Lots of partitions here on this NVMe drive. And before we test it, let's test the speed of the microSD card on the Orange Pi 5. Let's just bring up the command for that, which is sitting, there we are, we'll run that. As usual, I'm using a SanDisk Extreme Pro microSD card with a read speed of up to 100 megabytes a second. So the result we've just got here of 65 megabytes a second really reflects the speed of the interface here on the Orange Pi, and that's not bad for a microSD card read speed on a single board computer. The lowest I've seen recently was 20, the highest was about 80, so that's a pretty decent result. Now, just before we test the speed of the NVMe drive, let's look back to my review of the ROC 5B, which is based on an RK3588 with a PCIe 3.0 interface. And testing the same SSD, we got a speed of 1688 megabytes a second. So let's come back to the Orange Pi 5 with its RK3588S and a PCIe 2.0 interface to the M.2 slot. And we'll run the speed test, which I think I've got in the buffer somewhere. It's there we are, and let's run that. There we go. What's the result going to be? Oh, it's getting there. Very exciting. And there we are, 369 megabytes a second. And that is a key difference between an SBC with an RK3588 and an RK3588S system on a chip. The M.2 NVMe interface runs at under a quarter of the speed on the RK3588S and barely a tenth of the potential speed of the SSD. Now, 369 megabytes a second is not a bad speed, and it's far better than the speed of the microSD card, as we can see. So I still think that Orange Pi have made the right choice in selecting the RK3588S to allow them to sell a board at a very reasonable price. But do be aware, if you need an SBC with a very fast NVMe drive interface, you should not pick one with an RK3588S system on a chip. Greetings! Here I am back again, and we're now running Debian. It's got the same desktop wallpaper and it's got the same XFCE desktop, so it looks very similar, although there's a slightly different mix of software available in the menus. Down here, we've got the Cheese webcam program, for example, here in Debian. And if we go across to the web, here is the Orange Pi 5 page, which has got all the downloads currently available. We've tried out Ubuntu, there's Debian. When you click on these links, it takes you through to Google Docs, and you can see the files available to download. And we've also got available Android. I've not tried that out. And in theory, we can try Orange Pi OS, which is like a version of Android with desktop menus made available for Orange Pi computers. Except if I click on Downloads here, nothing is available, so I can't try that out right now. So let's come out of the browser, because there's a few other things to show you here. For a start, I've plugged in an external USB 3 SSD. There it is with various test things on it we'll be using in a second. And you might be thinking, how fast would that be if we tested it out as we tested out the NVMe SSD? So here we are raring to go, and we'll run that external SSD drive test. Really a test of the speed of the USB 3 interface on the Orange Pi 5. What are we going to get? There we are, 363 megabytes a second, a very respectable result for an external drive connected to the Orange Pi. Now, the other thing I've done here is to install various software applications. So for example, down here under Office, I've installed LibreOffice, and it runs up very nicely. Here we are entering LibreOffice. That didn't take too long. It's good to see we can use a word processor on the Orange Pi 5. Let's do our normal type hello, if I can spell it, and select it all and put it into a nice large font. That is the standard word processor test. There we are, that worked. No problems at all, so we'll come out of that. And as you're hopefully seeing, the responsiveness here is very good. This is a very usable desktop system. I've also installed under graphics, I've installed GIMP, the GNU image manipulation program, which will come up now hopefully. Again, very rapidly. So I'm impressed with this. It's running off the microSD card, but it is impressive. Let's just do a new document like that, and paint a few apples, shall we? There we are, working very nicely here on the Orange Pi 5. We'll quit out of that though, because we've seen enough. We've seen enough to see it works without any problems at all. What else have I installed? Oh, I also installed somewhere here Blender, just to really push things to the limit. This is a bit too much for the Orange Pi 5, really, in terms of it'll come up fine in a second. Come on, you can do it. There it is. But if we try and do anything in the menu here, you'll see that it struggles a bit. It sort of leaps around. I try and do a rotation. We can rotate, but it clearly is a bit graphically heavy to do 3D modeling here on the Orange Pi 5. But Blender does work. That is good to see. So let's also come out of that. And finally, I've installed Kdenlive. There we are down there, the video editor. Let's bring that up. Here it is. And this runs up fine, and I have tried out various little things with it. Let's bring in my test edit over there, at least the start of my test edit, because if I take my lots of docs clip and drag it down to the timeline and move it across like that, and suddenly the system has completely locked up. Sadly, Kdenlive is not stable in Debian here on the Orange Pi 5. So what I think we'll do is to change operating systems, and by the magic of filmmaking, here we are back in Ubuntu. We should never have left, should we? It looks very similar, but honestly this is Ubuntu. And here I've also installed Kdenlive, and here it is very stable. And I've loaded in the test edit that I've used on other SBCs in the past. And the playback here, admittedly using proxies, but that's not unreasonable on an SBC doing video editing. The playback is very good. Even with a dissolve there, works very well. Far better than it worked, for example, when I ran this test on the ROC 5B. And talking of the ROC 5B and other single board computers, let's run our test. Let's go to Project and Render, and I've got my script set up to render out this simple edit. So we'll start the script like that, and to see how long it takes. And to let you know, on a Raspberry Pi 4 8GB model, this took 2 minutes and 19 seconds. On a Latte Panda 3 Delta, an x86-64 based SBC, it took 17 seconds. And on a ROC 5B, it took 1 minute and 24 seconds. So let's speed forward in time and see how long it takes here on the Orange Pi 5. And there we are, it's finished. and a fantastic result. 52 seconds to render out this test clip on the Orange Pi 5, which is very, very impressive. Massively better than a Raspberry Pi 4, but also massively better than a ROC 5B. I'm very impressed with that. Let's give a gold star to the Orange Pi 5. The Orange Pi 5 is a most excellent single board computer. It's got a great specification, it's very competitively priced for that specification, and only 6 weeks from launch, the software support is also good. Now, it's not perfect. I have had the occasional error message, but nothing problematic. And as we've seen in this video, the desktop experience on this board is very fluid. It's very good for an ARM SBC. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.